$1,000 of passive income. According to this guy, it's what you will make with his crypto trading bot. And apparently everybody can do it in 10 minutes only, no coding background required. Sounds super legit, right? Well, no, this is a scam and it will steal all your money. In this video, I'm going to expose this scam and explain how it works. We are going to go through the code of the trading bot and I will show you exactly the tricks that I use to deceive people, and I will also reveal how much money was stolen with this trading bot. This is the YouTube channel that promotes this scam. And in the description it says, "Hi, I'm Dan, a Web3 developer from California. This channel is about teaching Web3 techniques and skills in an efficient and practical manner so that anyone can find fulfillment within decentralized finance." He basically introduces himself as a harmless Web3 developer who just wants to share with others his learnings. And notice how he mentioned that he's from the US is to come across as more trustworthy. So far, there's nothing suspicious. The only sign that there might be something wrong with this channel is that his channel was created very recently. Usually scammers get reported really fast and their YouTube channel gets shut down. So they have to constantly create new YouTube channels. So next, let's check out the video tabs. How to make Flashloan bot and get $1,000 passive income per day. So now it started to be suspicious. I also noticed that the same video was posted twice within a short interval with a different title, so the author tries really hard to push this video. And if we scroll down, there are some technical videos about Web3 development. The only purpose of these videos is to come across as a legit developer channel, that's it. So now let's check out his latest video, how to make Flashloan bot and get $1,000 passive income.
Today I'll be teaching you step by step how to deploy an Ethereum trading bot I've recently developed in the Solidity language, which can make you very easy daily passive income.
Okay, so the voice is just too good. It sounds like a TV ad. I'm pretty sure they hired some sort of voice actor. Perfect English, perfect pronunciation, it's a bit too much. And when it comes to what he actually said, he mentioned that the trading bot is a Solidity smart contract. What is this? Smart contracts are small programs that run on the blockchain. And Solidity is the programming language for smart contracts. And more specifically, Solidity is used for the Ethereum blockchain. And this makes sense since Ethereum is the most active blockchain. However, there is something a bit strange. Usually, when you have a trading bot, there is a backend that monitors trading opportunities and optionally a smart contract that is used to execute those trading opportunities. But for the trading bot of the video, we only have the smart contract part. I don't understand how it can work if there is just a smart contract. Anyway, let's keep watching.
To put it simply, the bot, which I like to refer to as a slippage bot, allows you to automatically trade a given token from the Ethereum blockchain without needing to manually transact through traditional methods.
Okay, so I never heard of a slippage bot. Slippage means that the price of an asset is impacted by large trades. For example, if someone buys a lot of token, the price of the token will go up as a result. So I'm guessing that somehow a slippage bot makes money from this price movement. But I'm not sure how, so let's keep watching.
It takes advantage of decentralized finance platforms such as Uniswap to sandwich transactions for arbitrage.
Okay, so you mentioned Uniswap, which is a well-known decentralized exchange. On Uniswap, you can buy or sell tokens on the blockchain by using their smart contracts. And he also mentioned a sandwich attack. It's the name of a trading strategy and it's probably the strategy that is used by the trading bot. But it's a bit strange because in the title of the video we have the word Flashloan, which is completely different from a sandwich attack. It's a bit confusing. So we need to look at the code to understand what the bot actually does. But before, you need to understand what is a sandwich attack. Let's take an easy example with stocks. Let's say that I am your stockbroker. You want to buy a large quantity of, let's say, Microsoft stocks. You send me your order so that I execute it. And this is a large order, which means that it will move the price significantly. This is called slippage. Me, as your stockbroker, I can make money very easily from that. All I have to do is to buy some Microsoft stocks before you. Then I execute your buy order, which makes the price go up. Then I sell the stock that I bought for myself at a profit. In the end, you bought the stock higher, and I got to profit from this little operation with very little risk. This is what we call a sandwich attack. And we can also do sandwich attacks for crypto tokens on the blockchain. But a sandwich attack is slightly more complex on the blockchain. But don't worry, I'm here to break it down. First, we need to talk of the mempool. When you buy or sell tokens on the blockchain, technically you send a transaction. That's a signed message with the details of the trade that you want to execute. These transactions aren't added to the blockchain right away. They have to be processed by validators. Validators are computers that validate and add transactions to the blockchain. When these transactions are sent to validators, they are put in the mempool. The mempool is a temporary memory that stores the transactions that are still pending. Validator monitor this mempool and pick some transactions to include in the next block of the blockchain. But how do validators pick the transaction to be included next? It's easy. Validators want to optimize the profit, so they just prioritize the transaction with the highest transaction fees. Alright, so now you understand what is the mempool, but how does it relate to sandwich attack? I'm glad you asked. To make a sandwich attack, you have to monitor the mempool. The mempool is public, so everybody can look at it. And when you see a large trade, you can trigger your attack. So for that, you will send another transaction to buy the tokens, but with a higher gas fee, which means that validators will process your transaction before. Then you send another transaction to sell the tokens, but with a lower gas fee this time. So in the end, your buy transaction will be included first, then the transaction of the victim, then your sell transaction. You buy low, you sell high. And once you have done this, congratulations, you can call yourself the new golden gecko. But not so fast. You just know the theory, but how can you make it happen? Here's a schema for you. This is your backend where you will monitor the mempool. And for that, you can use a blockchain API like Infura. This is the mempool, and this is the smart contract of a decentralized exchange like Uniswap. So for example, in your script, you will monitor the mempool for any large buy orders on Uniswap. And as soon as you detect a large order, you quickly send the 2 transactions of your sandwich attack. You wait for the transaction to be mined, and finally, you receive your profit. Nice plan, except that there is a little problem. Our good friend on YouTube doesn't mention any backend code at all for his trading bot. He just mentions a Solidity smart contract. But we don't need any smart contract for a sandwich attack. That's really strange. You know what? I think that we're gonna need to roll up our sleeve and check out the code because there is something really fishy here. Okay, so this is the code of the trading bot. It's a smart contract coded in the Solidity programming language. To use the trading bot, according to our good friend, we are supposed to deploy this smart contract on Ethereum, execute the start function, include some money in the transaction, and a few hours later, we should see some profits on our wallet. And if you wait even more, we should see even more profits. As a professional smart contract developer, I can tell you that there is something not right here. Transactions are mined very quickly, between 15 seconds to 1 minute. It doesn't take a few hours, unless the network is congested. And also, a transaction is executed just once. It's not an ongoing process, unlike a backend script, for example. So why are we supposed to receive even more money if we wait longer? A smart contract doesn't work like that. I smell bullshit on that one. But let's not stop here. I want to show you exactly where this will steal all your money. So this is the code of the trading bot, and we are going to start with the start function. This is the entry point of the smart contract. Very important detail, this is a payable function, which means it can receive money. And of course, to make the trading bot work, our good YouTube friend tells you to send money to this function. Moving on to the first line of the function. So we call a start exploration function, which itself takes as an argument the result of the fetch mempool data function. When you first read the code of a contract, you shouldn't try to understand everything at once. I don't know what these 2 functions do, and we are going to find out later. For now, we are just going to stay in the start function and try to get a high-level understanding. So we know that this returns an address, and next line we make this address payable, which means that we'll be able to send money to this address. Cool, so maybe it's our address, right? This is to receive our profit, right? I hate to disappoint, but I don't think so. Someone will get this money and it's not gonna be you. And next line, we transfer some ether to this address. This is very suspicious. How much ether is sent there? To know that, we can inspect this function here. So here's the function definition. Let's check out the comment. Returns the memory address of the first byte of the first occurrence, blah blah blah. Looks like it's doing something complex, right? Well, no, because if you look carefully, you will see that the function just returns the ether balance of the contract. And then we have another function defined just after with a lot of complex stuff, and it's just to confuse you and hide what this function actually does. Smart guy, but we're smarter. Okay, so let's go back to our main function and recap what's happening. So at the beginning, you send some ether to the function, and at the end, the ether balance of the smart contract is sent to an address. And it doesn't look like it's going to be your address. And in between, we don't know what happened, but we are going to find out. So let's check out this function, fetch mempool data. The comments say that it iterates through all mempools to return the one with the highest possible returns. What? There is just one mempool, and a smart contract cannot interact with the mempool. Only a validator node can, and it happens outside of the blockchain. So this is complete bullshit. Anyway, let's keep reading. So it's supposed to return a string from this other function. So let's check this other function. Very interesting. It looks like the beginning of an address. So going back to our main function, next it calls another function, fetch mempool edition, which also return a hard-coded string, which looks like a fragment address. Then back to the fetch mempool data function, the rest is the same. We have all these calls to functions that return fragments of address. And at the end, we concatenate all these strings together and we return the string. So that's a very convoluted way to return an address. It's obviously made to hide the address of the attacker and confuse people. Okay, so now we understand the fetch mempool data function. The result is fed to the start exploration function. So let's check out this function. It accepts a string and returns an address. The code looks pretty complex, but all it does is convert a string variable into an address variable. So going back to our main function, it means that all this line does is return the address of the scammer. We have deciphered everything line by line, we have read every function, and at no point these smart contracts call Uniswap and try to make some trade. All it does is first receive your money, return a hard-coded address, take all the money you sent and send it to this address. And to confuse you, it uses some misleading function names and complex code to give you the impression that it's doing something smart and complex that you don't understand, but that probably makes a lot of money, right? And it even have a lot of code that isn't used anywhere. It's just one more tactic to confuse you. Okay, but I'm still wondering something. How much money this guy made out of this scam? So for that, we need to know the address that received the money. So I duplicated the start function and I modified it to return the address that is created there. I deployed a smart contract, I called the start function, and surprise, surprise, we have the address of the scammer here. And now if we go to Etherscan, we can find this address. And in the internal transaction tab, we can see all the victims. This one lost 0.06 Ether, this one 0.4 Ether. And total, the scammer was able to make more than $1,600. All these poor people lost money. That's terrible. And I know what you're thinking. What if you try to run this scam by yourself? You just need a YouTube video and some Solidity code. Everybody can do it. No, don't get any silly ideas. Scammers who do this have no idea what they're getting themselves into. Their YouTube channel is gonna get shut down really fast. Their crypto address is gonna get blacklisted from most exchanges, which will make it really hard for them to convert their stolen crypto into fiat. And bonus, they will become research criminals that might end up in jail. Why would anyone do this? Especially when you have so many legit opportunities to make money as a Web3 developer. When you are a skilled Web3 developer, sky's the limit, and you can make 7 figures in a few years. I've done it myself, and no, it wasn't easy. It's hard, but it can be done, especially if you give yourself a few years. And if you want to learn how you can make 7 figures as a Web3 dev, next you absolutely have to watch this other video on my channel. This will completely change your career, and I'm not exaggerating. That's it for now, see you next time, bye.